So the MICAT project assesses indeed, and this you can find also in the previous presentation, assesses a number of the multiple, some of which relate to the macroeconomy and the microeconomy. So this is what we will discuss mostly today. And starting with a general overview of how the energy efficiency measures can actually bring some macroeconomic implications. So the energy efficiency measures generate demand for energy efficiency goods, such as insulation material and new electrical equipment, that will create direct, indirect, and reduced economic impacts on overall and sectoral economic to the demand for the specific energy efficiency goods. The indirect relate to the intermediate products that participate in the value chain of these energy efficiency goods and bring these indirect economic effects. And then the reduced economic impacts are those that come from the overall effects that we see in the economy. And also these bring then related employment implications. Now, the energy efficiency measures can also result in changes in the imports of energy carriers, and this has subsequent effects on the trade balance of a country. But they also affect energy prices and thus the competitiveness of the firms and the cost of living for the households. And finally, they affect the fiscal revenues and expenditures through taxation on energy carriers and energy-related subsidies. So this is just to give a brief overview of how the energy efficiency measures can actually interact with the macroeconomy. Now, what we did in MICAT is to develop a number of indicators that can actually assess this type of macroeconomic impacts. And for example, some of the key questions that we try to respond to, whether energy efficiency measures impact GDP, what are the type of sectoral shifts that can be expected, if there will be employment benefits, and if there are any competitiveness gains for the economy. We mainly use a static Leontief multiplier approach. We'll explain in more detail the methodology in the next slides, in order to be able to replicate this process and be able to have these tools easily used by the wider public and the users. So we try to have, let's say, the least resources possible in order to actually achieve the estimates of economic impacts and give this first step towards understanding the economic co-benefits. So a number of indicators were developed. We present some of those here. These are related to the macroeconomic impacts. And today we will focus mainly on 3 of those, on the impact on GDP, the employment effects, and the impact on competitiveness. So let's start with the impact on GDP. So the motivation is indeed to understand the GDP implications of energy efficiency measures, and this is an ex-ante assessment. So we assess what will happen if a specific measure will take place. We follow this static approach in order to assess the value added that is generated due to additional demand for specific sectors that deliver these energy efficiency goods. And the data requirements, we try to have minimal data requirements again, so that this can be a work that can be easily replicated and used by different types of users. So the limitations that we should consider here is that we assume that this additional demand for energy efficiency goods is indeed additional and does not substitute existing consumption or any type of investments. And this is then allocated to different sectors, and this allocation is based on expert judgment and is uniformly applied across all countries. Now, we do not consider for structural changes, nor do we consider for the impacts on imports or changes in prices and factor markets. So in essence, what we assess is the investment or expenditure by energy saving measure. We then allocate this to the different economic activities, and I will show an example later. And through the Leontief multipliers, we can then assess the additional GVA, gross value added, or GDP that is generated in the economy. Now, for example, and this is crucial to our analysis, how we allocate the specific energy efficiency measure, for example, expenditure on the building envelope or in heating fuel switch. How do we allocate these to demand for economic sectors? So this is done mainly through expert judgment, but also through the literature. And for example, in order to invest in the building envelope, we see that most of the expenditure would then create demand for construction, services and works, but also for other non-metallic mineral products, basic metals, and to a certain extent to services, retail, but also engineering services. And similarly to other measures, I mean, we just give an example of 3 measures here, but this has been done for an extensive list of energy saving measures that was identified in the MICAT project. And then through the use of the Leontief multipliers, what we do is indeed estimate, for example, what would be the annual gross value added generated for example, 150 million euros spent on space heating and cooling in Germany. And we see that this would result in around 94 million euros additional value added. Now, a similar approach is followed for the employment assessment. Here, what we want to understand is that what are the employment implications and what would be the level of employment generated because of these new energy efficiency measures. And through the sectoral approach, then we understand to which sectors this would be generated. Again, similar limitations hold us in the GDP indicator. So we assume that this is additional demand and it does not substitute existing consumption patterns of households or investments by the firms. And there are no structural changes considered. Similarly, to before, a starting point is the investment or expenditure by energy saving measure, and then through the Leontief employment multipliers, we assess the economy-wide employment generation. And just to give you an example here again, so if we have, for example, annual investments of 150 million in Italy on improving the building envelope, for example, we could expect around 2,100 additional jobs generated. And we see that this, for example, has a high coefficient of employment. Now, with regards to the competitiveness, we again focus on this static approach. But the idea here is to understand the impact of the measures on the production cost of a firm. And what we do here is that we use, again, the input-output analysis to understand what is the ratio of the energy cost in the total production cost of a good. And through that, we understand then what would be the implications in the unit cost of production. Now, if we also assume an elasticity in demand, so how would demand change because of this change in the unit cost of production, then we can also get insights for changes in total demand for this product because of the energy efficiency measures, and understand directly the implications on competitiveness. Again, here there are a few limitations. So we do not goods that could be associated with these energy measures. So our starting point is really how much less do we spend for energy, and we do not consider for prices of other intermediate or factor inputs to production. So we assume that the prices remain as such. And again, here the input this time is the change in the energy purchases by subsector, assuming that these energy efficiency measures have taken place. And then through the information of the ratio of energy purchases in the total cost of production, we can then assess the change in the unit cost of production and potentially the change in demand based on electricity, on the elasticity of demand. So this is a brief description of how we approached these three different types of indicators on understanding the implications of energy efficiency measures on GDP, employment, and competitiveness. We have developed a number of other indicators and are working now to include those in the MICAT tool that will be available for all users. And just to give an here we take the construction sector, see the type of measure that could be that could bring, for example, around 20% of reduced energy costs, and see how this would then result in changes in the unit cost of production. Now, along with these macro-related indicators, we have also developed the energy security and energy delivery indicators that my colleague Frederic can describe in more detail.
Thanks, and good afternoon, everyone. So, sorry. Right. So, to start off, yeah, energy security has gotten some more scrutiny in the last couple of years, unfortunately, in the aftermath of the invasion. So, we've been looking at it even before. And the approach hasn't really changed, but we can see in hindsight what sometimes would have been the smarter thing to do. So when we look at energy security, basically energy efficiency can do a lot in this field. So on one hand, it can just reduce the overall volume of imports. It can drive down energy prices or fossil fuel prices, and it can also drive down the dependence on a few main suppliers. But it's not as if that always happens all at the same time. It's more about a political decision for what benefits a government wants to go and what it is willing to do for it. So next slide, please. So when we have when we look at the gas market, for instance, and pretty much every energy market, so you'll have some kind of a supply curve. So if we take an example country, let's take Germany, and just assume they have a certain group of suppliers willing to provide certain amounts of energy to Germany, we'll see that they always have their own production prices and then a certain demand. And at this point, basically, that's the highest price that's going to flood into the market. And since it's a rather transparent market and every actor in the market more or less knows what this strike price is going to be, what we see is that all the actors are going to adapt to it. So all the actors with that are below are going to adapt their margins in order to be close to the strike price. And now when we have a reduction in gas demand, what we can do is basically three different things, or what can be done scientifically. All right, so yeah, what do you mean? We talk about energy imports dependency, so about the energy that is just directly consumed. So we talk about gas, oil, and coal, basically. So when a country just wants to go for the fossil fuel prices, what we see is basically they're just going to take the highest suppliers out of the market in a way, and that's going to bring down the strike price, and that's going to reduce the energy price. However, that can also mean that domestic energy is going to be removed, because often, especially in the case of Germany, which produces around 4% of its gas demand, this energy is rather expensive compared to what we imported. I mean, that's the reason Germany had the issue with Russia, because the gas was so much cheaper. So that's one way to go. Another way would be to say, all right, we just want to reduce the volume of imports. So that's what we see in the second graph in the upper right. And there, basically, you're just going to remove all the foreign parts. And this is going to bring down the unit price, of course, as well, but less so as in an example where you just go for removing the most expensive parts, no matter what they are, since you'll have more parts that are expensive in your average costs of energy imported. And then the last solution you could go for is reduce the dependence on main suppliers. So you could say, we got to go strategically for reduction of Russian imports. In hindsight, that would have been rather smart to do. And the issue with that is, of course, it's not how the market operates in itself, because the market is always going to go for the cheapest price first. So what you need to do there is just kind of set political rails on the sides, so just to steer those decisions in the way that you want politically. And of course, that hasn't been done in the past. So that's why why the market often went for the simple reduction of fossil fuel prices, so the first option. However, that is still 3 possible outcomes of energy efficiency, and that is what this tool wants to show, basically the potential to achieve those benefits. I mean, it's still up to the governments to decide what they want to do, but what we provide with this tool is the calculation to show them basically how much could they reduce their import dependence if they were to cut out foreign imports, and not only the most expensive ones. And in the same way, what we're going to show them is how could their supply diversity increase if they were to remove the imports stemming from biggest importers, basically, and try to have a more even distribution of suppliers and more suppliers, basically. So that is 2 things that we can show, but it's more like a potential, because in the end, both things at the same time are often rather difficult to achieve, and it's a political decision what is done. And when it comes to the monetization, the difficult part is, since you have this kind of merit order principle applied, and Europe is kind of the remainders markets on a world stage when it comes to fossil fuels. So it means it's the market that players from around the world send their remainders if Europe is willing to pay enough. So it's really complicated to model this part without modeling the rest of the world. So the monetization of energy security is going to be something for the future in a follow-up project where we're going to look into this in more depth, because within the scope of the first MICAT project, it's just not doable, because it's more than a simple model that, like the Leontief multiplicators, for instance. Right. So the second indicator I would like to look at is the integration of renewables. So what we're looking at here is, given the increased prevalence of renewables in our markets, in our energy systems, of course, we need demand response potentials to cope with peaks and also the valleys. And energy efficiency can play a role in this and can increase those potentials, but it can also reduce those potentials. And that's what this indicator is looking at. Because on the one hand, we have electrification, which is often seen as energy efficiency when we look at heat pumps, because they are far more efficient than alternatives. But we also have reductions in overall consumption, and also thereby reductions of potentials. So on the one hand, we have this electrification, which can increase the demand response potentials. So for instance, heat pumps can allow this because heating can be flexibilized in times of low demand. In addition, we also have the effect that insulated buildings can make it easier to shift heating to periods of low demands, while badly insulated buildings basically need to be heated when you want the temperature to be adequate. And electric vehicles can also be used as storage for energy and to cover those potentials. So we see this can have a positive impact, but also, of course, some facilities, in particular industrial facilities, are already used as as demand response potentials. So for instance, cooling cooling industries have often used their the possibility to cool at times where electricity was cheap. And we have a lot of industry flexibility, which has provided capacity in terms of demand response, which is going to be reduced when this industry is getting more efficient. So that is something we have to take into account as well. So how does MICAT approach this issue? So we use a twofold approach. On the one hand, we basically scale those potentials with the electricity consumption, because demand response is bound to be linked to electricity. And on the other hand, we look at the different sectors and the different improvement actions and have specific coefficients, basically saying a certain industrial sector is more likely to have those demand response potentials than another. And by this, we adapt the electricity consumption with those coefficients to make viable estimations of demand response potentials and their change through energy efficiency measures. Right. And the monetization of this uses a twofold approach. So on the one hand, we look at what does it cost to provide this demand response service if it isn't through demand response potentials in industry, in households. So for instance, just how much would a battery cost? So a battery storage. And on the other hand, we're looking at willingness to accept price. So there's a lot of studies asking companies what would be the price for them to provide a certain demand response service, and somewhere in between, that's the price we are taking to assume the costs of this integration of renewables. Thanks.